if you were to pick the right methodology or the right tool, whether it's Cursor or Claude Code or HumanLayer or whatever it is, how would you know? Other than vibes, is there any way you would know? How do we make it as easy as possible for humans to leverage their judgment and intuition in the construction of software? I'm telling you right now, the answer is not stop reading the code, and the answer is definitely not like burn out your senior engineers by sending them like a mountain of PRs that are 50% slop code every day.
Hi, I'm Joe Ruscio, a general partner at Heavybit, and you're listening to High Leverage, a regular series where I explore how modern software teams are scaling through better culture, tooling, and processes. High Leverage is brought to you by Heavybit, the leading investor in enterprise infrastructure software. To learn more about us, visit heavybit.com. Welcome, everybody, again. Another episode of High Leverage. Super excited today to be joined by Dexter Horthy. Dex, welcome to the show.
It's great to be here. I'm excited to yap for a bit.
Yeah, we're definitely going to yap. It's always helpful to give listeners just a little bit of background, like your origin story. I always like, what's your origin story? How did you come to acquire these superpowers? But yeah. How did you come to found HumanLayer?
Yeah, so I mean, I wrote a little bit of code during an internship in high school where I was like working at NASA. They had gotten this like high-res data set of the South Pole of the moon, and they needed like basically like navigation code, like code that would help you be, I'm at point A, I got to go to point B. How do I get there without like exceeding some max incline, basically?
Like a rover or something?
Yeah, how do I get the rover from point A to, it can only go up max like a 40-degree angle, like cliff, and there's rocks and stuff. So we'll get, and then it's like basically wrote a really naive, like non-math version of Dijkstra's algorithm for like pathfinding, basically.
Nice.
So that was fun, and I didn't write code for like 4 years, and then I was like doing a bunch of like CS stuff in college, and I was actually a physics major, but I ended up doing some CS, and then I took my first job in Chicago at a company called Sprout Social, and basically realized immediately that the most valuable people on the team were the people building the software factory. We didn't call it that at the time, but it was like the people doing the developer productivity, the sandbox environments, the previews, they just built all the infrastructure that enabled everybody else to ship faster, to test their changes faster, to deploy well, to have confidence, to react to alerts, all this stuff.
Yeah, this is kind of in like the kind of DevOps pipeline heyday kind of.
It was like 2013. So it was like we barely, like DevOps was a word, and it was like a, the cult in Belgium in like 2009 or whatever. So it was like starting to become more mainstream, and like we had a little bit of Chef, and then we went to Ansible, and then we went back to Chef, and like it was like those days of like still like pets more than cattle. There was no Kubernetes, there was no like service catalog, like everything runs everywhere. There was no Docker, but
aspirationally cattle, I guess. But
yes.
the goal to get, which I guess probably speaks to why those people were so valuable in terms of like there's like moving the needle closer and closer to that outcome.
There was a lot of things that were not really documented in code, which is like, okay, this server runs these 6 services, and this one over there runs these 2, and two copies of those run on that server over there. They all had names. They were actually, they called it the barnyard. There was like pig 1, pig 2, pig 3. There was like cow 1, cow 2. And it was like, oh yeah, the ingest jobs run on pig, but the other things run, it was wild. Yeah.
Okay. Oh, great. And so you had this guy, I guess, epiphany that like building the thing that builds the thing, you get a lot of leverage.
Is higher leverage.
Higher leverage. Yeah,
that's the name of the show.
Yeah, well, that's exactly why we're here, why the show, and why at Heavybit we're like really focused on. I've always felt like that's a great spot to create value.
So anyway, I drifted there on every team I was on since then, and then eventually I kind of woke up and was like, it'd be way cooler than like building internal tools for engineering teams at like random startups or even like big like, thing-looking companies. Like, what if we had a company where that was the product? It was like we were building things that helped other people ship their software factory.
Yep.
And so that was how I landed at Replicated, spent a couple of years there writing code, contributed a lot of core parts to our like container scheduler and things like that. And then Kubernetes.
Shout out to Replicated, Heavybit portfolio company, Mark and Grant. We love you.
Absolutely wonderful guys.
Yeah.
Yes, was there for a while, and then like ended up doing basically like go-to-market stuff for a couple of years of just like, hey, look, we just parted ways with our head of sales. Do you want to just like spend all your time working with our customers? And like, I love it. Our customers were awesome. It was like HashiCorp and Puppet and DataStax and all these incredible developer brands. And you were sitting down with like the principal engineers at all those companies.
The smartest people of those companies.
The smartest people of those companies. The ones that were like, and also like solving the on-prem problem is like the nastiest, ugliest problem. It's like, I know you've heard the story about GitHub where like, oh, anyone can work on anything they want. And so they would hire people to work on GitHub Enterprise. And then within 3 months, they'd be like, this is not fun. I'm going to go work on something else. Yeah, this is actually hard. And so they actually had to, I heard at some point that they actually had to change that rule at some point. I don't know, it was like before or after the Microsoft. It was like, okay, if you get hired for Enterprise, you are not subject to the work on whatever you want rule. You like kind of have to stick around and make this happen because nobody likes it and we need to get people who can do it.
Yeah, somebody has to chop wood and carry water.
Yeah. But basically, so I've been working on software factories my whole career.
Yeah.
Either like helping other people do theirs and writing YAML in the trenches with them on the go-to-market side, or actually like building it internally ourselves.
Yeah, and Replicated specifically, they were on the vanguard to the GitHub Enterprise analogy of like wrapping up software and helping people deliver it, quote unquote, on-prem.
Right. Yeah, on-prem will be AWS VPC, but it was like you send the app to where the data is instead of forcing people to send their data up to some like multi-tenant SaaS.
Yeah, yeah. But which requires just like, I guess, an incredible degree of not just automation, but actually like correctness and like a lot of different scenarios you have to adapt to.
If you think managing a distributed database in your own cloud is hard, like wait until you have to go debug it in someone else's cloud.
I was going to say, like when cow 1 and cow 3 are in someone else's barnyard, it's like a whole other story. Yeah.
And then it's like our job was to help other people trying to do that and make their jobs easier. And then take the lessons we learned and then like pack it into the product and make it easier for anybody to debug or run or launch or install or upgrade software running in a data center they couldn't control.
Got it. Okay. So yeah, and now you're in, I guess, a more customer-facing role. So you're talking with helping these people solve this problem at all of these industry-leading companies. And yeah, their customer list was incredible. It
was great
back then. Yeah.
I remember Mitchell Hashimoto came to our office and did like a fireside chat with Mark. And I was like, holy, this is legit.
This is cool. Yeah. Yeah. So I guess at some point, you finished up your journey there. What led you to take a step out and start your own company?
It was something I kind of always wanted to do. And like, I don't know, this is advice I give to founders. A lot of people are like, well, I want to work at a startup for a couple of years so I can see what it's like. And then I'll go start my own thing. And I'm like, yeah, or you could just go do it. Like, That's what I did. I was like, okay, I want to go to, and I was, okay, I did engineering, and then I did go-to-market, and then I was a PM for a year Replicated, because I was like, I just spent 4 years in the trenches with our customers. I have a lot of ideas about how we can make the product easier to use and stuff. And I was like, okay, cool. I got all the Infinity Stones. Now I can go be a founder. And it's like, I also ran into, being an SF, you run into a bunch of founders who are 24, and like, they are learning all those things, and like, it hurts more when they learn. Like I had the blessing of like, okay, I got to like test all this stuff out, but it's like they did learn it faster because they had to. And so if you're thinking of like, should I be a founder or should I go learn? It's like you will learn all the same things. It may be a little sloppier, a little more chaotic, but you will probably learn most of the same things eventually, and you will learn it faster if you just go do it.
Yeah, I agree with that. So you jumped in.
Yeah, it was just like, I want to do something. A friend tried to recruit me as like CTO for his startup, and like I bootstrapped a bunch of infrastructure for them, and I was like, look, this is cool, and like I think actually like I'm gonna go do my, like, I love those guys, but I'm like, I'm not gonna wake up every morning like jumping out of bed to solve this problem.
Right.
And so I was like, but I do want to go do something. So I started shopping around. I was doing like co-founder dating stuff, and like a buddy of mine basically was like, I have this problem. I've had it my whole career. I'm working on an open source thing to solve it. And I was like, oh, that's cool. Let's like go spend some time hacking on that. And so like we basically jumped in and started building a product around this like data engineering tooling, which bad timing because I think that was around 2023, 2024 when the data engineering party was kind of over. There's like a lot of money that went in on the tail of like DBT and Fivetran, and then everyone kind of woke up a couple years later was like, this TAM is smaller than everybody thought.
Yeah, RIP, the modern data stack.
I mean, it's great. I mean, the people who use it is like, it's just obvious now. It's kind of like, oh yeah, Kubernetes is like, yeah, of course.
Yeah, it is kind of fascinating, not a tangent, but the whole data stack, I think, is arguably one of the only like pure ZERP category phenomenons.
It's crazy. I actually don't think it's a bad product. I just think it's a really hard problem to solve. Actually, similar to shipping on-prem. Like I talked to other founders who like thought about on-prem and tried it, and they're like, you can solve it with code, but it's one of the few problems that we encounter that squarely has to be partially a people problem. Like even if you solve 60% of the problem with code, you're still dealing with the random IT staff at every single company, and everybody does it differently. And like, it's just really hard to generalize. And that's why they just like try to avoid it. And I think data is the same way. Is like, if you're freaking GitLab and you have like a like perfect product engineering culture where every feature is tied to a customer metric and you know every single thing and everything rolls up into this perfect metric graph and everything you do in every part of the business can be linked to some top of line outcome, like great. But most companies don't have that. Most companies don't have the like skill or the will to create that, and no amount of software can solve that.
Yeah, well, the skill of the will to create is kind of interesting because it's one of those things where like a partial commitment or partial budget or like you have to be willing to go all the way, and also like the financial commitment that requires, and then like the outcome on the other side has to justify that, right? Like,
Yeah.
and so you're gonna be out with a lot of places where it's like, oh, you put in not quite enough, but I guess it's a very like bimodal outcome. Like you either like
Yeah.
fully commit to it and get a good outcome, or you spend a bunch of time and money and get pretty much nothing.
Dump 20% of your burn into Snowflake for
Right.
5 years, and like your company still works the same way it did 5 years ago.
Exactly. Yeah. Yeah. It's one of those classic, like you do have to ask the question, like, well, what changed? Like we spent all this money, what changed?
Yeah.
Okay. So you started there, but I think you pretty quickly kind of.
About 9 months, and it was just like, okay, this is not going well. Like we had a bunch of really exciting pilots with really exciting logos, and none of them converted. And my co-founder kind of burned out. So I was like, cool, I'll take it solo. Like we're gonna go. We've been like playing around in the AI space. I'm like, I'm just gonna go all in on AI. This was 2024, so it was like GPT 4.0 was out right around then. So it was like, okay, cool, like this agent thing. And so we built this like human in the loop thing. I know this is supposed to be the short version, but it was like human in the loop for AI agents. Like, what if I'm running an AI agent on my laptop and I go get a coffee and it wants to send an email on my behalf? What if I just got a text message and I can be like, yep, go for it.
Okay.
Like the thing that kind of like got commoditized with the OpenClaw explosion. So
Right.
but we did that business for about 9 months and like got some revenue and got some cut, but it was like it felt like we were like too early, or it was like, I don't know. Do you know Michael Greenwich from WorkOS?
Yeah.
He has this bit. He's just like, if you want to build a really good like horizontal dev tool startup, you kind of have to plan it around the emergence of a standard. And for him, I think for WorkOS, it's kind of SAML 2. It's like enterprise was like, okay, SAML 1 was impossible, right? Or it was just like very hard, so not as many. SAML 2 is like, okay, it's built into Active Directory, it just works.
Right.
If we can just like plug in and make this integration layer really easy, then like everybody will just be like, as long as you integrate with this protocol, we have the best implementation of it, kind of thing.
Yeah. I think one of the things that's been interesting or fascinating, I want to get your take on, and we basically, we invest exclusively in infrastructure, developer tools. And one of the things that's been really kind of, I mean, both leads to, I think, like a generational opportunity, but also maybe a generational challenge in that the substrate that you're trying to build on continues to change so quickly. Like the conversation we would have had in this room at that point in time versus like 6 months later, versus like 6 months later, versus like 6 months ago or 6 months from now, probably. Like what matters is changing so quickly. Like how as a founder are you navigating that? Like, and you've been navigating it now for 2 years.
Yeah.
Right. And so first of all, how has that been? Like, as you look back, like.
Yeah, I mean, there's some hard learned lessons. Like we ditched the human in the loop thing because I think it was like too early. There was no standard, right? So anyone who wanted to implement our stuff, it was like, what we learned was like it looked like there was an ecosystem. At the time you had like CrewAI and LangChain and Grip Tape and all these like agent frameworks that was like, seemed like, okay, if you build against this kind of emerging standard, then you'll be able to plug into anybody's app and it will just work.
And they'll probably figure it out and come together on something.
Exactly. And it's just like, I went and like did hundreds of customer interviews with like founders and founding engineers and like everybody I could find who was building an AI company, mostly vertical AI kind of stuff, who was selling 6-figure deals, who was doing 7-8 figures in revenue. Every single one of them was using none of that. And I hadn't realized that. That was like a hypothesis. I was like, oh, everyone was building it from scratch. Nobody was building in the same way. I mean, there's some core things, but the core like thesis was like, just use the API directly and build your own pipelines and workflows because it's changing too fast. And so there was no standard for us to plug into. And so basically when we wanted to get people to try HumanLayer, use it, integrate it, they were all really excited. Like, yeah, I'd much rather buy this than build it. Oh, I have to change my architecture that much?
Yeah.
And so it's either like for bigger companies, like, hey, can you come in and do it for us? Which we decided we didn't like doing. And then there was the like, okay, cool. Like I'm just going to build this part myself.
Yeah, well, I think, it's there's all this talk in the last, I don't know, 6 or 9 months at this point about like forward deployed engineers. And I mean, there is something to like, hey, the adoption of AI or agentic workflows
in an enterprise is like significantly more nuanced than, historically adopting like horizontal SaaS.
Yeah.
Right. And maybe you need humans to help with that. Or if it's something where it's actually not really generalizable at all, can you hide that with humans? Right.
Yeah.
And I think knowing as a business, like, wait, which of these are, if we're doing forward deployed engineers, are they truly connecting that like last, not even mile, like quarter mile? Or are they actually re-implementing the product at each customer site from scratch?
Exactly.
Right?
Yeah. Are you beaming anything back up to the mothership, or are you just a consulting company?
Right. And I think there's a lot of consulting companies in Palantir-shaped clothing right now. So this is like, what was this, late 24, early 25?
This was like early 25, basically. Yeah. And so like from all these conversations, I kind of like distilled out some principles. And it was actually like 12-factor agents was basically this guide that we wrote that went like super viral. That was like principles for building AI agents. Actually, most of it is still, I think like probably 80% of it, I would still be like, yes, that's good advice. A little bit of it has aged out, but I'm impressed how I'm actually like surprised how little of it has aged out at this point. But it was basically like we saw, and it was almost like the manifesto of like, here's why HumanLayer is actually like not a good shaped business, is like, because the right way to build agents is to solve your own problems, optimize, use workflows, and not just like call tools in a loop and stuff.
Right. Yeah. Well, it's funny because that goes all the way back to the 12-factor app.
Yeah.
From Heroku. I actually, in my prior life, I had a talk which was 12-factor observability.
Of course. People like the number 12.
Yeah, it just works. But I think a funny thing with the 12, I'll have to ask James, one of the founding partners here is a co-founder of Heroku, although Adam Wiggins wrote the original, if I remember correctly. If the 12 was actually a number they were targeting, or if they just ended up with 12, like could it just easily, if he had a bad morning, would it be the 11-factor app?
So 12-factor agents is funny. It's actually 11. And then I just added the 12th one.
You got to. Well, now you have to, right?
The 12th one's kind of a meme. It's like, oh, your agent is a stateless reducer. And like, hey, the FP nerds, like, have fun.
Yeah, but I think the original, I think they now all have at least, I think given enough time, there's probably some truism where like at least 4 of the factors end up being like not. Yeah. If you're hitting 8 out of 12, I think you're in good shape.
Yeah.
So I don't know if that's where you're clocking yourself right now, but.
Yeah. But we kind of wrote that and it was like, okay, cool. Like this is clearly resonating with people, but it was also like, I don't know if this is like the company I want to build. And we had been doing a lot of stuff with like using coding agents and brownfield code bases and had like discovered a lot of things. And like I spent a lot of time with some of the people that I would consider like, I want to say like 99.99th percentile in terms of like skill at using AI for producing software. And basically it just, once again, like distilled a bunch of really good ideas, put them into practice, actually like refined it to work. I don't know if you noticed, like all these really good AI people like end up being kind of like lone wolves because they're so much better than everybody else. We're like, okay, how do we make this work on a team? How do we make it collaborative? How do we make it like easier for teams to standardize around a particular AI workflow? And that was kind of like the seed of HumanLayer or CodeLayer or whatever. We had an open source IDE basically that was like, you launch this thing, you can grab it off of GitHub, and it lets you manage a bunch of Claude sessions in parallel. Many such products.
Right. But I think the framing of as like a novel IDE is probably smart. I mean, one of the things that has kind of, and especially before Claude Code was launched, and I think there's places for IDEs, but there was always part of me that was like, it feels strange to assume like there's this alien technology that we've like conjured up out of the sand.
Yeah.
And the best way to interact with will just happen to be the paradigm we've been using since the 1970s, right?
Right.
And yeah, it was when, I think for me, when the first time I started using Claude Code, I was like, oh, this, and not that this, it's like the end all be all, but it's like this directionally now is something different, right? Where the actually sitting in the text window or looking at the code is like a secondary, right? It's not the primary interface.
Yeah. And we've been on a crazy journey of like, you should just read the plans and don't read the code to like, actually, you know what? I don't think models will be able to write good code unattended. And like, I'll get into all of that. But like,
yeah,
the feeling I have right now is like, we basically need a new GitHub. We need like a GitHub for the things that happen before the code is actually produced. So I don't know if you want to call them specs or plans or design docs, but like there's all these things that good software engineering teams have been doing for a really long time.
Well, this, by the way, I do want to like dig in on that, but a thing that has like fascinated me for the last few years, having been, I've been investing for almost 10 years, but prior to that, I spent 20 years like running engineering teams and like really focusing on this. And there's a whole bunch of activities and practices and processes that top decile, high performing teams, right? Like if you look at the practices they engage in, that historically most software engineering teams that were more, I'll charitably say median teams, right? We're like, we don't have time for that. That sounds like a lot of work. They're all things that I think are like table stakes are absolutely required to really use agents and agentic coding.
You think you need to have good Dora metrics?
No. To be careful, I don't know that that's the best, but more in terms of like what's a high performing team. But there are some aspects of that. I mean, the Dora people are actually pretty hard at trying to figure out what the new version is. But just things like having a spec, right? So like,
but that wasn't in Dora.
Yes, yeah.
The whole point of Dora, right, was it was like, we're not going to tell you a tool to use or a process to follow or a role to hire for. It was like the first time up until Dora, my take, what I think is magical about Dora, and I know a lot of people now think Dora is like maybe kind of BS or like, I don't know, like a little hand waving marketing stuff. But like it was the very first time up until that point, DevOps was like, you knew it when you saw it. and no one could just, it was like, well, it's not using Jenkins and it's not hiring an SRE and it's not like using Chef.
Well, actually, the problem was way back then. A lot of people were like, "What's DevOps?" and it was using Jenkins.
Yeah, exactly.
Or using Chef, right? Like using Jenkins or using Chef. It was like, oh, it's a tool. And the classic kind of DevOps refrain was like, well, it's people and culture, not tools.
It's a culture thing, right? It's like there's a team that uses Jenkins that's not doing well, and there's a team that's using Jenkins that's doing well. So it can't be the Jenkins part. So what is it? And Dora was the first time we were like, okay, if you can ship from your laptop to production fast, if you can do lots of small changes instead of a couple big ones, if you can ship without breaking prod most of the time, and when you break prod, you can fix it fast, then you're a high performer. And that's like finally a thing a CTO could be like, okay, no more like being gaslit by engineers on what is and isn't DevOps. I can measure this now.
Yeah. Well, yeah, it's fair. Like what it did was it measured a bunch of lagging indicators and said, if these lagging indicators are present, there's like a pretty decent chance you're doing good things.
Yep.
But like,
doesn't tell you what to do.
Doesn't tell you what to do. Yeah. And like any metric, if you like subscribe to Andy Grove and like high output management, if you don't have like the complementary kind of thing to track whether or not the metric's being gamed, it can absolutely be gamed.
Right. What is that good Hart's law? Is like as soon as a metric becomes a goal, it's no longer a good metric.
Yeah. Unless I think Andy Grove's kind of insight was like, well, as long as you have some other metric that's like intention.
You have like a guardrail metric or something of like,
So the classic, it's like his had to do with like fabs because he was at Intel. But like, if the manager at the factory like redlines this thing in this way to hit the actual target metric, I'll be able to measure this other thing that tells me like quality's going down and
someone's cheating. Yeah.
Someone's cheating.
I have one counter argument to that I think is a metric that's very hard to game. Simple one. So we help people measure engineering productivity. We kind of end up having to because like our product's thesis is like, hey, we're gonna help your engineers ship twice as fast. And it's like the question I always ask when we're talking to customers is like, cool, if you were to pick the right methodology or the right tool, whether it's Cursor or Claude Code or HumanLayer or whatever it is, like 2 months later, you're sitting there, you're like, this is great. This is working. We made the right choice. I'm a great leader. My team is awesome. How would you know? Like, other than vibes, is there any way you would know? And most people don't have measurement. Some people have measurement, it's actually pretty good. Some people have measurement and it sucks. But the thing I always recommend to people is like, measure the number of pull requests. Managers say, well, but if we measure people on their number of pull requests, then they'll just make lots of little pull requests instead of like one big one. And I'm like, yeah, pretty sure that's what you want, dude.
Right, yeah. Well, another thing, I tweeted this like a year or two ago, but at the time, because it's funny, this I do think was still in question, but I was like, even hypothetically, if the use of models in coding is like net neutral, all the things that you'll be required to do to use models will actually generally make you better as a software engineering team in terms of like putting out plans. Because in the early days, it's like, oh, if you want the model to work, like, well, you got to have tests.
Yeah.
Right. It's sort of like was like a stone soup thing. And it's like, oh, well, if you want the model to work good, like the way to not have to write code is to have good tests and have good specs and have good, like,
You're sitting on your 20-year-old Java monolith and you're like, all right, I guess I'll add a linter. Fine.
yeah, I have a linter. It's like all these things that historically you'd have to like beg and control, engineers to do, and they didn't want to. But yeah, bringing it back to specs, my last team, I always believe in like, it's like, okay, you're an engineer. You've pulled down a ticket off of a Jira or Asana or whatever the hot, like, linear, today. And unless it's like a quick bug fix or something. If it's like, hey, go build a new feature or whatever, like
the agent's not one-shotting that in a sandbox. That's not how that works.
right. Well, write like a one page, and we had a little template, like write the one page spec. And that's because it's like, generally speaking, way better to have the review by the other. This is all pre-AI, but like having a human review a one page English spec before you've written code and say, hey, I like this, but not that or that or that, is like way cheaper than fighting through code to get to the same.
It's like, well, so like writing the code takes hours or days.
Yep.
Reviewing the code for anything substantial takes hours or days. And so it's like, okay, cool. Can we spend like 30 minutes in a, like, sit down and read a spec and like basically save hours at the review time by just kind of doing high leverage work, which is like, let's align ahead of time. And like, I don't know, the process that we've found works best. And like, we do this internally. It's available in HumanLayer. We don't force it on people. And actually my goal is like, every team has a different kind of way of applying leverage based on their code base and all this stuff. But it's like, okay, get the product requirements right, which is like looking at mockups. We don't do Figma anymore. We use HTML mockups. Look at mockups, understanding what's the problem to solve, understanding like, if possible, we try as many of our specs as possible have like, what is the business metric? Like, how will we know that this worked?
Yep.
And sometimes it's something simple like adoption. People are using it. And if they're not using it, then we come back to, we either make it better or we throw it out. Sometimes it's like someone can do this workflow in 20 minutes instead of 10 minutes, but like something measurable, because then you can like feed that back into your agent and have it like help you iterate. I mean, just like you would feed it back into your product team, now you can do it for the agent.
Well, hypothetically, you would have fed it back into your product team.
Right.
But historically, most places wouldn't.
Yes.
Because honestly, it's one of those fascinating things. Like any startup founder, it's like, or team, you're like, oh, it's fun to build things. And we know we want to build this. And you were in customer facing roles. It's a lot less fun to say, well, what will the business value be? And how do I actually validate that will be the business value? Oh, I got to go talk to a bunch of people. I got to
Well, the number of calls, even as a PM, I was like, look at all these Figma mockups. We're going to build this feature. We're like, oh, that's really sick. And then you're like, would you pay an extra $200 a month if we built this? And it's like very uncomfortable. They're just like, And I was like, oh, you willing to put that in writing? So it's like, okay, getting to that uncomfortable part of the conversation is the trick. But if you can do that first, this is Marty Kagan, right? It's like, figure out if people are going to pay for the thing before you spend 6 months building it. Figure out the lowest fidelity prototype that you can do, whether it's internally on your team deciding what to build or even putting in customer hands, that lets you decide if this is even worth spending another day on.
Yeah. Yeah, there's a old saying in academia, never let an hour in the library save you 3 weeks in the lab.
Yeah.
And it's like there's the software engineering version of that, which I think, again, going back, like I think the agents now taking on more of the work of actually generating code kind of brings to the forefront.
Well, so some of the mechanics have changed, right? Like, because you've replaced, like, person takes a ticket off the queue and builds the thing, and that takes hours or days, with like, agent takes a ticket off the queue and builds the thing, and now that takes 10 minutes, 20 minutes, depending on the thing. But like, usually it's done in under an hour. And then the review still takes hours or days.
Yeah.
If it's a substantial thing. And like, there's two answers there. You read the code and you suffer through it, or you turn the lights off. You do the lights off software factory, right? You know about this?
Yeah. I'm curious to take, the dark factory.
The dark factory, right? This idea of like, hey, there's like car manufacturing plants in places where they literally have like the lights are off because there's no people there. It's all automated.
And they don't have eyes or they don't have optic nerves that require light to do their job.
Yeah. And so the core thesis is kind of like built around this idea. It was like for a year, it was just like vibes that I had and that lots of good engineers I talked to had. And like, I actually did a bunch of research and dug into like obviously like what's going on inside the labs is a little obfuscated, but you can look at the benchmarks as a signal of like, where is the state of the art at like evaluating the quality of these models at coding tasks. And every single benchmark is like, basically the model knows the whole problem up front. It doesn't have to like make decisions over time. It's not like discovering the problem as it goes. And it's even like most of the like past generation of like sweep, anything before 2026 is like 15-minute problems. Here's an issue off some Ruby repo from 10 years ago. Like, can you fix the bug in 15 minutes?
And here's some like probably clear tests that like you can tell whether or not it worked.
Exactly. And so it's like a very, like to do reinforcement learning.
It's a very tight loop.
Exactly. You need what, like, I was talking to Adias Many about this from DeepMind. He's just like, maintainability has no fast oracle. Like you need an oracle to do both benchmarking and reinforcement learning. And what we don't have right now is like, because the cost of like the penalty function of bad architecture is measured in like months and years, it's like very hard to train a model on this, or very expensive.
I think there's just so much architecture too that is like really situation dependent, right? It's in terms of like there are great architectures for one set of problems that you put them in another set, and it's and then even at least historically, in the history of software engineering, I think there's this book, Design Patterns from the early 90s.
Oh man, I read that when they only had a C++ version available. Now you can do it in JavaScript, but I had never read a line of C++, and I slogged through that entire thing, man.
Yeah. Well, there's a point in time, and like that book and Martin Fowler's refactoring book. But one of the fascinating things, there's a couple of those design patterns in there, because I think there's like 20 patterns or something. Some of them are still amazing and are used in pretty much every piece of software you'd use.
Well, most of them are built in the language too, right? Like flyweights and singletons, like you just get that in the syntax now. You don't have to like build an object around it.
Yeah. And there are other ones where, or this goes back even to like inheritance in C++.
Right.
Everyone's collectively like, that was a terrible idea.
We should not have done that.
Yeah. And I mean, I did date myself. I mean, I was an undergrad in the late 90s in computer science, and like, there's so much inheritance being stuffed down your throat. Like the tests would be like, oh, you have a dog and a cow and a cat, and how would you lay out the classes, and what would be and now it's all like interfaces, not inheritance, whatever. Composition.
Yeah. Rob Pike got that one right.
Yes, absolutely.
I think he nailed that one.
Yeah. But going back to
come back to the dark factory thing, right?
But even like your benchmarks, like if it's not like, oh, the code's correct or not, or the code passes a speed test or not, it's like, oh, how maintainable is the code?
Yeah. The question is if I stop reading this code and let the agent just cook for 3 months, am I going to hit a problem that the agent can't solve? And am I then going to have to go slug through this 3 months of code and spend weeks fixing a thing? And the whole time that's happening is like, my site is down, my users are pissed, and like, I'm miserable.
Yeah. I'm increasingly starting to feel like November 2022, when ChatGPT hit, to roughly November of last year, was like this sort of 3-year preamble, sort of warm up, like clearly something interesting is happening, and it's kind of like sticks and stuff. You can kind of do stuff like you don't have to go to Stack Overflow anymore, or you can say, hey, I need a piece of code that does this, and can like generate like a reasonably good thing. But it was like November last year when Opus and OpenAI's corresponding, it was GPT, after the 5 dot whatever.
Yeah, when the like Codex model came. Because it was Codex, and then it was GPT-5, and then like 5.1 was a Codex, and then eventually it was just like they're fused back into one model, and Codex became like the harness and the product around it.
Yeah, but it was like the models from late last year, so about 3 years after ChatGPT, where suddenly it was like a step change in that, like, oh, the like fundamental atomic primitive of the kind of coding problem you can give it, and get a working result, is now something where you could imagine that as a building block that, like, oh, I could see at least certain pieces of software being assembled out of this.
Yep.
And then that's sort of the next immediate question, because I know people were trying to do software factories and loops and prior to those models, but I think it was, and which is really important. Like I say, there's always important work to have someone just kind of bonkers at the frontier
doing like ticket to PR workflows. It's just
doing
like
something just that, like, hey, this barely works. It has no business in any professional setting.
Yeah.
But it does work.
Yeah.
To some degree. And so that sort of just shows like, okay, that's the limit. Like someone always has to understand, like, what's the limit?
Yeah.
But then if you're a professional engineer, your task is like, okay, that's the limit. Where short of the limit are we supposed to stop? Right?
Yeah. And how can I like move as fast as is safe without like mortgaging my code base or like getting paged at 3 a.m. because now everything's like breaking all the time, or, getting fined millions of dollars because of some compliance thing. It's like at a certain point, like there are classes of people and classes of code bases where like I would recommend reading lots and lots of the code. Like that turning the lights off is just not an option and won't be for a while.
Yeah, well, I think software exists on this like spectrum where you have everything from like life and mission critical software, right, at one extreme side, and then like, enterprise software a little short of that, typical enterprise software a little short of that, all the way down to like toy app side project.
My vibe coded like Minecraft for slop fork or whatever, right?
Yeah, where 60% of the time it works all the time, and that's fine. But a lot of people, particularly listeners here, like kind of operate in that professional enterprise zone. And so I guess, for starters, what do you think is feasible with models today in terms of historically, like, let's just keep numbers simple, like 80% of an engineer's time. So if you were able to spend like 20% of your time on this like high cognitive, like thinking, figuring out like should the trade-offs of the architecture be? That's the other hard thing about testing good architectures. Architectures like trade-offs all the way down.
And you don't know what's coming, right? Like if you know your whole roadmap for the year, like yes, you should hire an architect and have them plan the whole thing out. But like if you are a business, like obviously if you're a startup, but even like if you're any kind of scaling business that is like needs to maintain flexible and agile and lean and like be able to turn on a dime to like catch new trends and catch new waves of AI and new things are possible, is like you need to optimize not just for like shipping, not just position of like where is your product, what can it do today, but your velocity of like how fast can you change and how even accelerate, how fast can you change direction.
Yeah. Now we have this like I said, we have this alien technology that in theory can take the 80% of your time that was spent like laboriously, like it's kind of funny to think, like manipulating a physical device using your muscles to communicate, from one kind of ether into another, into the digital ether thoughts that you...
Was it 80% of your time?
Maybe more. I don't know. It just depends on, I think, your role.
I don't know. We work with some enterprise customers and like the vibe I get and like what we kind of had starting to happen at Sprout when we were getting above like 200 employees was like, okay, it's a 2-day feature, but like we actually are being disciplined about estimating it at 2 days. Like the coding is going to take 3 or 4 hours, but we're going to sit in a meeting and talk about it. We're going to plan it. We're going to have unknowns. We're going to then like go write the code. Then I'm going to spend a couple hours getting a review and taking the feedback. And I'm going to spend some time like testing and verifying. So the actual end-to-end time is like 2 days, even though the coding took 3 or 4 hours. If I use Claude to write my code or AI to write my code, okay, that part's 20 minutes now, but I haven't sped up any of those other things.
Yeah, well, and let alone, we were talking about DevOps pipelines, but like, how do you get the code out to production? I mean, that was a big part of what that... Well, I don't know how much of the planning or I would loop into the code or testing, certainly. Like, I think you could argue, at least with Claude, you get whether or not it's good, you get the coding and the testing kind of in a swoop. Where are you guys focusing HumanLayer today? What do you think is the right approach with the model capabilities today for a typical, like an engineering team at a Sprout Social?
Yeah, a couple hundred employees, anywhere like, that's mostly like our bread and butter is like a staff engineer at a 300 engineer team will like find us, use it for a couple weeks, and then like decide to start rolling it out to their team.
Yeah.
And the basic thing that I think works really, really well is like is exactly what we've always been doing. I mentioned there's that like, okay, you're gonna spend a quarter of your time doing planning and like reviewing and like aligning on what we're gonna do. You're gonna spend a quarter of your time coding, you're spend a quarter of your time getting code review and like fixing it and like fixing all the bugs, whatever it is, and then you're gonna test, verify, deploy, whatever it is. I think the number one like tiny advice, like the one word advice is like seek leverage. Find ways to take that, do 30 minutes of planning up front, use AI to help, right? Because like writing an architecture doc could take you 3 days. Like you talk to a principal engineer at a pre-AI like enterprise, they're spending a week writing an architecture proposal and it's like a 10, 20 page Google doc. And then that goes to the engineers and then they just talk about, okay, how are we gonna split this down and how's it gonna be milestones and like what does the PM care about? Like all of this stuff you can accelerate a lot with AI, but it's still like, there's a lot of leverage from having humans in the loop before you go write the code. Because once the code is written and then you're just yelling at the model in the pull request comments, like it's going to be a lot slower and a lot harder. And the chance that you'll have to throw it out goes like up, basically.
Right. Yeah. Well, the interesting thing I found in models, and this isn't just for coding, but even to your point, like, I don't know, making a presentation or an architecture doc or just saying like at a super high level, oh, just go do XYZ.
Yeah.
It will generate an awful lot of content, most of which is like at the extreme surface level from like a distance. You're like, oh, that looks good. And then as soon as you, try to like engage with the material, you're like, oh, I have to like cut 80% of this and tell it to go like.
So I do this in writing. I'm writing a very long post right now. And it's like, I was like, cool. Here's the transcript of my conference talk. Go write the headers. And just wrote all the headers, and I like tweaked the headers. I'm like, now go write the first beat for the first header, and I tweaked it and played with it. And it's like, now write the next beat, and like now it's starting to get pick up for like my tone and how I structure stuff. And so it's like the same thing is true of code. Is like, cool, like let's plan the high level. Give me the headers, right? Almost like I don't know, like if you were in C code, it's like give me the C header file, and then we're going to implement one function at a time. But like there is a way to do this where you're going 2 to 3 times faster compared to just like YOLOing prompts into Claude, and like compared to the like, I'm moving 100x faster, but I'm going to throw all this out in 6 months because it's going to go to slop.
Yeah. I was just talking with some founders this morning, very early stage, very senior technical experienced people, but they were setting up basically like a scaffolding up an initial like cloud infrastructure for like a distributed system. It's a little more sophisticated than just like a CRUD app. So, a couple different services. And they just, had Claude generate all of the Terraform or whatever as code. But then I think pretty intelligently we're like, okay, we spent like a day and it generated this whole thing, and you hit a button and it kind of goes. But now we're going to sit and actually work our way through all of it.
Yeah.
I think initially their thinking was like, oh, we're just going to spend a day or two reviewing it.
Yeah.
And what actually happened was they spent 3 weeks like pulling pieces out. And where they ended up was they were like, well, what we ended up doing was just pulling piece by piece. And as you pulled each piece out, you're like, oh, this isn't quite right. I got to change it, whatever.
Yeah.
And 3 weeks later, they have a great working thing that's like about 20% of the original footprint Claude, or I don't want to cast the model pumped out. And it's like in hindsight, that maybe wasn't a win.
Exactly. It's like, okay. And you can overdo this, right? Like some people just like try to get their plan perfect, whether it is. So like in our process, it's like you have the product doc, and then we have the system architecture, which is like high level, like what are the contracts? What are the data models? What's the flow? And like maybe like what's the shape of the new endpoints we're making, whatever it is. And then we get into actually a thing that I think most people skip, which I call program design, which is a thing a lot of people say, okay, if I get the architecture right, the model could just cook and it'll do my thing. But actually, like, you'll still have like weird try catches around everything. You'll have weird hacks of like this object over here is calling methods inside from an internal class from this object over here. The model has no intuition around, hey, that's going to make things harder in the future, because we couldn't teach it that during RL. We could teach it to solve programming problems, but we couldn't teach it to like care about the maintainability. And so we do the program design of like, okay, here's the thing we're building. And then we do the like an outline basically. And at any point it's like, okay, we're not trying to get it 100% right. We're not trying to one-shot the architecture, because like at that point, just write the code. But it's like, how do I spend 10 minutes to give me an 80% chance that it's correct, so that on the next phase I can spend 10 minutes and then spend 10 more minutes as we're like going from the 50,000 foot view to the 25,000 foot view to the 10,000 foot view to like, then we go write the code.
Yeah. Have you found, is there like a scale or sophistication of a piece of software at which point it's like, oh, well, the bones of this are like good enough and strong enough that I can kind of just actually let the reins out a little bit on the model, and I don't need as quite, or is this like just a constant kind of challenge where you're trying to get it to the exact right, like throttle or whatever you want to call it?
I think it's like not a black and white thing. I think like every code base is evolving and adopting and incorporating new patterns as you need new functionality. So like there's parts of our code base where I'm like, I know I can one-shot this. Not only because I've seen Claude one-shot this or Codex one-shot this many times in the past, but also like I know that part of the code base. I know the examples of what to follow are very close to where it's going to have to write the code. So I know it's going to find them, and I know it's going to follow the patterns. And I have pretty high confidence that it's only going to have 5 to 10% rework needed max. And there's a low chance of that happening.
Yeah, I've been kind of the mindset, or it feels intuitive, that in any sufficiently sophisticated software project, there's what you just said. There's going to be this gradient where there's like, oh, there's certain places in the code where we can kind of let these things be almost unattended, or like a dark factory of sort of thing might almost work. But then there's other parts in the code, and whether that's like the hop path or as Claude would say, the load bearing part of the code, like, where you're like, we probably always want some eyes on both the plan and the output.
You have some instincts about what's probably going to not go well. And it's like, cool, I want you to like give me without actually like, because again, it's like, what is the thing I can do that is, 20% of the effort of reading through the code and fixing it that gives me a, 80% chance that I won't have to go read the code. I think about it in terms of like expected pain of like, how likely is the model to get this wrong? And how hard will it be if it is wrong? Like, it was like, I don't know if it's going to get the color of the button right, but I'm perfectly happy to like vibe polish that afterwards.
Right. Yeah. What's the cost of being wrong?
Exactly. And what's the chance? It's a standard risk modeling. But like when we, in November, December, we basically like took our open source, chucked it, like, and basically rebuilt it from scratch because it had like, basically this was the end of my like, don't read the code cycle. We had gotten to the point where it was easier to rebuild from scratch than it would be to like repair everything that was wrong.
Yeah, I've seen you speaking about this before. One of the things that is curious to me is, I mean, you guys were kind of at vanguard, or at least kind of at the vanguard. Given what the shift in models, like how much, like not that the current models are like some magic solve, but like I think in hindsight you could be like, oh, of course, in March of 2025, like Sonnet or whatever couldn't do that. Do you think the models that exist today are closer, or like how much of that is just like fundamentally won't ever work, relatively speaking, with transformer architecture versus like, oh, it's just not, we're just not there yet?
I don't think it's about the architecture. It's about like, what can we teach the model during RL? And there's a very like, I say like GPT 5.5 or 5.6 or even Fable, I will tell you right now, will not write code that gets better over time. If you give it 5 features a day for the next 6 weeks, you will wake up to a ball of spaghetti. Now, these models can create incredible refactors. Like you turn on Ultra Code, you can go change 100,000 lines of code in an afternoon. But they will not do that unless you tell them. And so the thesis of the dark factory is like no human steering about the code and how it looks. And if you are not going to steer it to architect, if you're not playing a role in how should this be designed and taking your 20 years of hard-won intuition about like what makes software suck to debug versus what makes it easy to maintain, then you will not by default get good code. That's kind of where I'm going. Like, that's my take.
Yeah. And, this has kind of been my experience even just with side projects, since I've been building a lot of stuff, especially since last fall, when actually I think the things get good enough that with the amount of time I can dedicate to coding.
No, the scope of and like complexity of a thing you can do without caring about the code grows with every new like model like improvement.
Yeah. Well, but the thing that has been interesting to me is I definitely have repeatedly now had this experience because I've got some stuff that, I've been running my personal production or whatever you want to call it for like 9 months. You'll say, oh, go bang out this new feature. And it's like, great, I've got it. And it actually, it's kind of like pretty sophisticated, messes with a bunch of stuff. It works, one shots it, works great. And then you go to roll and just use another part of the piece of software and just completely host.
Yeah.
Just totally broken.
And the more you go, it gets harder and harder to fix something over here without breaking something over there.
Yeah. It's just, I think part of it is just, like you said, by default, it just sort of puts like these blinders on that just, I don't know, I think I've been curious about, is that just because I haven't like loaded or written some skill that's like, hey, you are a senior software engineer, like always consider what you might be breaking when you do something.
I think if that skill was possible, we would have it already.
Right. But I guess the question, it sounds like this is endemic. This isn't just like my complete lack of effort in my harness or something.
Well, again, this is what it is like if you put in zero effort, it will do what you want. And I actually think that Opus 4.5 was not as smart as Opus 4.1. Okay. The reason why Opus 4.5 caused the blow up is because even though it wasn't as like deeply intelligent in terms of like problem solving and focusing along like paying attention along large, like I think Opus 4.1 was actually a larger model. It also tell because 4.5 was much faster.
Yeah.
But Opus 4.5 was 2.5 times faster and it was squishier. Like it was better at like you put a low effort prompt in, you get something great out. And that was what made the change. And that's actually I think how all of the go to market for the like model harnesses from labs is like, how do we make this more accessible to more people? Sometimes at the cost of expert users.
Yeah, well, I think part of what they did too is like improve. I think with some of the RL techniques, right? Like improve how the harness could use the model. Like the harnesses have, I think, gotten better too, or at least the foundation labs.
I mean, they've gotten very good at up until Claude Code, the way you built a good agent was like you got a model and then you gave it a set of tools and you tweaked your tools and you did a bunch of evals and you did JEPA or like the DSPy thing and you like changed your tools and optimized all the prompts to work for whatever the model wanted to call. However the model wanted to behave, you were like, how do I make the harness fit the model? And with the labs, they did that, and then they took the model and they trained it in the harness. Now, how do we make the model better at calling the tools that are already in the harness instead of just doing it? And this is like OpenAI gave a talk about this in November that was basically like, if you are building a coding agent harness and you do not also own the model, you are going to be a disadvantage of a team that can like tweak the weights of the model to fit their harness, however their harness works. Yeah. I mean, this is what OpenCode does. Is the reason why OpenCode is like tied with Claude Code on the leaderboard is because when OpenCode calls the Claude Code inference, it looks exactly like all the tool definitions are exactly the same. All the responses are exact. When you read a file in Claude Code, it comes with all the line numbers. Everything is mirrored. And if you mirror all of that and you mirror the exact harness that the model wants to be living in because it was trained for it, that's how you get the best performance.
Interesting.
Yeah.
Going back to the dark factories.
Yes.
Just like, couldn't every fifth feature you put almost like a tracer round, right? Where you put a thing in the factory, which is like, hey, refactor everything or like clean it up, right? Or like make it more maintainable. I don't know.
I mean, people do this, right? And the same thing with code review agents. Review this code and make it more maintainable, whatever it is. I just think that like what I have seen is like the models don't know what well-factored code is. Like they can read books and apply what's in the weights. But most of what's in the weights is what they learned in RL, and we can't teach maintainability in RL. So unless a human is like, when Fable came out, I had to do a 5,000 line refactor of our like ugliest React code. And I was like, okay, go do this. And it like did kind of what I wanted, but not quite the shape. And I gave it some pretty good steering. I was just like, okay, like remove all the prop drilling and all these like patterns that make the performance bad. And it brought in a bunch of patterns that I don't like that like make the code base worse. It's like, so like you just tell it, hey, refactor and make it better. Like you may or may not get good results, but the thing that actually makes it better is like, you're like, okay, we have this anti-pattern over here and this thing over here. And so like we should, there is a ceiling where it's like human judgment is required above that ceiling.
Okay.
To get past it. Like, yeah, you could say, hey, refactor this, and like you might get good code, you might not. Whenever I tell a model to like YOLO refactor something, it's almost never worth it. I almost always end up throwing that commit out.
Okay. Yeah, well, I guess the ceiling is an interesting point because I think one of the challenges for like engineering management is like trade-off, right? Like how much should be invested. I mean, Yagn, right? This is like the classic, like you aren't going to need it, right?
Exactly.
Which varies, like for this particular piece of software, is this an internal tool? Is this like something that customer is super dependent on? Is this something critical? So like, what ceiling am I okay with? Which I guess would kind of dictate like how much review or not. How do you, because my kind of perspective has been that like, I mean, future's not evenly distributed, but if you've like fully adopted these things or you're trying to adopt as much AI as you can in your code generation, like human review of code and human taste is the bottleneck.
Yep.
Right.
So how do you apply it in your workflow as efficiently as possible?
Efficiently as possible. Yeah. How do you do what you can to the extent you can remove that bottleneck or reduce its kind of constraint?
Yeah.
So like what do you do? How do you do that?
I mean, I think this is why we're building this space because we think this is super important. And like, you think about what GitHub did to software development is like, I can now go to a CTO and say like, hey, CVS is kind of a thing, but like, there's a single distributed, like there's a single centralized place where I can like put my code together and release it from this place. And it's always up to date and it's always the source of truth. And like, before that, what were we doing? We were emailing patches back and forth on like the Linux mailing list.
Yeah, or you were FTPing a tarball up to a server to deploy, which hopefully was the right one. Hopefully you tarred up the right directory on your laptop before you did that.
And nowadays we are in Slack sending prompts back and forth. And it like kind of feels like the same thing. And it's like, how do we build a place for people that is optimized for collaboration on things that are not code, but are like code and are attached to code and live in the context of code? And create like workflows that are super human friendly that allow us to extract that. I don't like to say extract because it sounds, but like, how do we make it as easy as possible for humans to leverage their judgment and intuition in the construction of software? And I'm telling you right now, the answer is not stop reading the code. And the answer is definitely not like burn out your senior engineers by sending them like a mountain of PRs that are 50% slop code every day.
Right. Yeah, because you have only two choices. One is stop reading the code.
Yep.
Which, for your point, you're clear about how successful you think that can be. And then the other one is like, okay, well, if the code has to be read, which by the way, yeah, I think you make a good point, which not a lot of people are, is like, there's real value if the code needs to be read or reviewed, or at least some chunk of it does.
Yeah.
Then everything you can do to, before that code gets in front of the human, like improve the likelihood that it's good and it's terse and like it's not like the, hey, good news, your job, here's your machete. You have to like figure out which 20% of this is actually that's review.
Yeah, exactly. Go spend 3 weeks picking apart the Terraform to
find the right thing. Yeah.
Yeah.
I'm curious, a kind of segue I did want to talk about today. Just the last week, Kimmy, Quen both dropped like what appear to be very capable open weight models, which by the way is a continuing pattern that's now been going on for a few years.
They said it would be July that the Chinese labs caught up to the US ones, and it's like someone looks like that guy. We got that right.
See if he knows anything about horse racing. Yeah. What's your current thinking on where, and I guess particularly we could narrow it to like, coding agents, right?
Yeah.
Like, what do you think the future portends for coding agents? How much code is going to be written by state-of-the-art foundation models? How much is going to be written by open weight model? Like, what is the impact going to be of having these open weight models that have these capabilities?
I mean, I think we're seeing the impacts of both the frontiers competing and the open models hitting the scene is like, hey, we got more Fable 5. They kept saying they were going to cut it off.
Right.
5.6 drops. Okay, extend. I mean, you can have whatever theory you want. I mean, the Anthropic story is, of course, like, oh, we just wanted to make sure we could really service the demand, and now we're ready to.
Oh, yeah, they figured it out. They made a heroic effort to figure out how to.
We did it. We got you guys more Fable, and
right.
But no, I mean, I think competition is good for any market, and I think especially the competition between open and closed source is good. Like, I don't know, like we've done a couple evals on Kimmy K3, and like seems good. Like has some of the weird Kimmy ticks. Like we've tested every one of the Kimmy models as it comes out. We're working on being able to deliver GLM 5.2 inference to our customers as like part of the product because we think it's a really good. If you can run it fast, it's very good for certain things where it's like just put up a really fast quant of it, and like the FP4 quants are like actually like pretty good for things like code-based research and things like that. So like I love the open ecosystem. I love competition because it just like means we all get better stuff from even from the closed. It makes the closed models better having the open models in the arena.
Yeah, I agree with that. Well, and I just think particularly for enterprises, I've just always felt that. I mean, this is like where the history of open source software, right, comes from, is the benefits of like, oh, I can own this thing, or even if I'm paying a third party company to support the open source piece, but like the avoidance of like permanent lock-in, the ability to, for me, I always said with open source, it's for the vast majority of like enterprise users, it's not like, oh, free as in speech. It's the
I've heard that one before.
It's the right to inspect and right to repair. Right, as most people care about.
The tinkerers, all the people hoarding GPUs in their basement.
Yeah, well, it's just, if in the middle of the night I need your piece of software to do something, and I have good engineers on hand, like I can crack open the open source software, the database, and if I really need to, fix it.
Yeah.
With open weight models, I think just the ability, like if I'm a large enough enterprise and I have my own GPUs, quote unquote, on-prem, right? I can trade off like, oh, what subset of my tasks do I want to run on premium tokens? What tasks can I take a hit
for your knowledge workers that are running like summarizing emails and writing calendar events? Like you don't even need Sonnet. You can use like, I know I just talked to a guy from Anything LLM, this guy Tim. He's like, you have a workforce with a bunch of ThinkPads, and all these ThinkPads have like an NPU that no one knows really how to use, and they're just like, yo, run local models on your laptop, and like for most knowledge work, you can use a tiny little Quen model to do almost everything.
Yeah, well, I agree with that. So then coming back to the coding harnesses are best when their argument that they're like super tied to the model, that kind of future argues for ideally a coding harness that I guess is not tied to a particular model, or like am I going to need a different coding harness for each of my coding tasks that use different models? Or
if the open models catch up and they have like fully caught up, I can't tell you for sure that like K3 is a drop in for Fable. The vibe check online seems to say no. But like when they catch up or when they get close enough, you will see people building custom harnesses who think they can build a harness better than the labs will then do a fine tune of one of these frontier open models in their own harness, and they'll get the same benefit.
Okay.
And so it's that benefit that only the frontier labs have of that ability to tune the model for their harness, for their product, for their like, you know, step into the like one step up from the platform level into the product space. Now anyone can have that benefit.
Okay. Cool.
It's a good question.
Yeah. No, it's something that keeps me up.
Yeah.
I'm trying to figure out. I mean, it's just fun. I'm thinking some of the harnesses. I like Xe.dev is one of our portfolio companies, and
oh yeah, I have the HumanLayer daemon running on an Xe.dev box right now, doing some stuff.
Yeah, it's a great agentic workload hosting platform, vibe coding platform. They have their own harness. It's Shelly. It's
the Shelly thing.
Yeah. But it's kind of cool. It has a pull down menu, and you can just be like, oh, this is of the 15 models. Like, I want to try this one. I want to try this one. And it just feels intuitively to me, if inference is a commodity at some level, which I do strongly believe it's going to be, then there's this, going back in networking, there's this thing called the end-to-end argument. It was originally for like when people were arguing about like what layer, application layer or you know, network layer, transport layer, like different features should be in. And the argument was like, for most things, you want stuff closer to the application layer because that's the only place that all the context exists to really make the most fine-grained decision on a app-by-app basis.
You don't want to put your database sharding in your network table or something.
Right.
Yeah.
And so, so there's things right now where, I don't know, for instance, there's these routers and they're like, oh, okay, well, you know, historically, we've just been kind of this like dumb switch where you just say, hey, I want some tokens from this one or some tokens from this one. But like, maybe now what we'll do is we'll actually look at the requests coming in.
Oh, I don't think that works.
No. Well, it's just, just kind of like, it just seems like I can get why if you're there, you're like, oh, it would be a good thing for me to like automatically maybe route things to one model or the other, but you're missing some, like the application should be the one for the most part, I think, deciding like, this should go to Fable, this should go to, you know, Quen, you know, sub chunks.
Basically, bringing it like I think doing it at the inference like time decision is not. Yeah, you need to do that in the harness, and a harness is basically just like a giant DAG that like manages a bunch of different workflows, right?
Yeah.
Or a small DAG, I don't know. And it's probably, it's not acyclic. It's just a directed graph. But it's like, okay, cool, we're going to do this. Okay, this tool came back. Okay, we're going to use a Haiku model to see if it's safe. Okay, yes, then we run the bash command. Like there's all this deterministic stuff happening under the hood. It feels like just calling tools in a loop, but there's tons under the hood for any harness. And actually, I realized the thing I said was like, oh, people are going to do a fine-tunement of an open model and ship it in their harness. Like this is Cursor Composer. This is exactly what Cursor did, is they took like a Kimi base model, fine-tuned it on their data in their harness, and then now they have their own model that's fast and cheap and good.
Yeah. If you fast forward a few years, which is like infinity compared to what's happened in the last few years, right? What do you think the prototypical kind of software engineering team role looks like? Because one of the things, even whether or not code's being read, I just remain convinced that like humans have a very important role to play in software engineering for a very long time, at least like serious enterprise software. But what do you think the typical day of like a senior software engineer looks like a few years from now? Like, what do you think their kind of key tasks? And you know, Jensen had this thing where he was like, you can the job is not the tasks, right? Where it's like the job is the outcome. Like software engineers have had outcomes they've driven at a high level. Those outcomes still need to be driven, but the tasks are probably going to change dramatically.
Yeah, I mean, I think in the like short term, it's like still aligning and understanding, and like the level of detail that you need to align with on the model and the amount you can trust it to figure out what's under the hood like goes up over time. But I actually don't like answering this question like okay, you may have in your mind like there's a 5% chance that we have the infinite abundance AI world where it's like nobody has to work anymore, full AGI. There's also like the 5%, maybe you think there's a 5% chance that we end up in the Terminator, right? It's like we do a bad job at safety and then we all get like blown up in a nuclear explosion.
The bad AGI.
And then you think in the middle, there's a 90% chance that things just kind of keep getting better within like this range of like, okay, it might get better at 2x a year, it might get better at 1.1x a year, but like somewhere in there, it's going to keep improving as technology just improves over time for everybody. And I think it's easy to say like, cool, I think we're kind of still going to be on the same path and we're going to be caring about the code and we're going to be like having to play a role in this for a little bit. But it's like, I may believe that there's a 30% chance we get to that like abundance world. I may believe that there's a 30% chance we get to the, like we're living in the Terminator, but I still am probably going to live my life as if we're in somewhere in that middle range. Because nothing you do today matters if either of those first two things come true. So it's like the only thing you can really do is, unless you want to like go try to be head of safety at a frontier lab, which I'm not personally really interested in doing, then like you kind of plan for the middle path. So like whether or not I'm saying this is definitely how it's going to go, I'm like, this is what is worth investing time in, like understanding software engineering and software architecture and what makes systems good and what makes systems fall apart is very much like plus EV to keep investing there, keep caring about it, and keep building your factories around this idea that like, hey, we are going to need to be the stewards of this system at some level of abstraction.
Yeah. Well, I think that's a great note to end on. So yeah, thanks so much.
This is fun, dude.
Yeah, we'll have to do it again sometime.
Yeah, I'll give you the update in 3 months when I decide I was wrong about everything.
Yeah, let us know.
That's all we have time for today. High Leverage is brought to you by Heavybit, the leading investor in enterprise infrastructure software. To learn more about us, visit heavybit.com.